Hello, Brandon Clayton, the Algebra Guy here. Wanted to talk to you today about identifying terms, coefficients, and like terms. Extremely important concept when you're dealing with a lot of terms and trying to put them together. So by the end of this video, you'll be able to identify like terms in this type of group. So I want you to be able to say these are alike, these are like terms, and so on. So that's what we're shooting for. So let's start with some definitions. Today we'll answer the question, what is a term, what is a coefficient, and how can one identify like terms? So let's start with the first one, a term. What is a term? You'll often hear this come up, put these terms together, or what terms are alike. A term is a constant or the product of a constant and one or more variables. Well, what do I mean? So here's some examples. It's either a constant or the product of a constant. So if I look at, let's get my pen out here. So if I look at this order or this group, I have a constant. Remember, a constant is just a number. So here is a constant right here. So just that by itself is a term, or it can be the product of a constant. What does that mean? Product is talking about multiplying two numbers, the answer you get from multiplying two numbers. So this right here is a product of a constant. How is that a product of a constant? Because we have a 1 understood to be here, so 1 times a variable. This is a term also. So the product of a constant and one or more variables. So that's one variable. And 5, here's a constant times another variable, x squared. So this is a term. A constant times a variable a, that's a term. And 13 times two variables, that's a term. So notice that it doesn't matter that it didn't have to just have one variable, but it could have two if they're all being multiplied together. So that's what is meant when they said a term. What is a coefficient? Well, a coefficient is the constant that multiplies the variable. We actually just talked about that, but there's actually a word for that number we were identifying. So in this case, the coefficient is, the term is 7, and the coefficient is 7. Well, the coefficient is supposed to be multiplying some variable, but where's the variable? I don't see any variable here. Well, you can actually rethink about this 7 as having x to the 0 power, because anything to the 0 power is 1. So 1 times 7 is still 7. And I know we haven't discussed that, but that's something that you if you're wondering as far as the definition is concerned, how is that true? Well, you can think of it as x to the 0 power. This one's easier to see, this next one, 9 times a. What is the coefficient? Well, it's the constant that multiplies the variable. So this constant, 9, that's multiplying the variable a, is our coefficient. What about this one? Now, this is a very important one because the 1 is a coefficient, but you don't see 1 over here. Because every variable, if there's no number written in front of it, there's understood to be a 1 right there. So we know that there's a constant 1 multiplying that variable, y. That makes that a coefficient. And for this variable, x squared, we know that is a coefficient. That is 5. All right, what are like terms? Terms that are either constants or have the same variables with the same exponents. So either you can have constants or they have the same variables with the same exponents. So those two times when you're going to get a like term. Identify the like terms here. So I'll start you out and we'll do this together. So it can be a constant. So do we have any constants here? No. This is a constant. So this is a constant, and this is a constant. We're going to call both of these like terms. And I'm going to keep the same color so that you won't get confused. But I've identified like terms. Do we have any other just constants? No, we don't, because everything else is being multiplied by a variable. Now let's look at a variable with the same exponent. I always like to start with exponents moving our way up. So I would like to start with x to the 1 power, and that'll be here. So notice there's an x to the 1 power. Even though they don't write it, it's understood to be a 1 there. Just like we talked about with the coefficient that doesn't have anything there. So x to the 1, do I have any others that have x to the 1? Right here. So these two would be like terms. 3x and 5x will be like terms. All right, let's get a different color to identify our next one. So now we have x to the 1, and we have an n. So let's do the n. So we have an n squared. That's a term by itself with a coefficient of what? What was the coefficient here? Should be a 1. So there's a 1 there. So this is a term by itself. And we have another n squared with a coefficient. So that's another term. So how many terms altogether? Well, if you put all these together, we have 3 different types of terms. Of course, we have 6 individual terms, but 3 different types. We have one that are just constants, as we saw here. And then we have some that have x to the first power, and we have others that have n squared as a variable. All right, let's go do a little bit of practice to make sure this drives this point home. Identify the like terms. So let's start with our constants. I see that we have a 14 and a 23. So those are 2 of my like terms. So I'm going to cross those out. Got those done. And I don't see any other that just have a number. And I see that we have x and y. I'm going to start with x. Make this sure that's a 3. Do we have x to the first power? Yes, we do. We have a 9x right here. That's just to the first power. Do I have any other like terms that have x to the first power? And no, I don't. So that's just 9x. Do I have an x squared? I do have an x squared here and an x squared here. So those 2 are like terms. So that can be 7x squared and 5x squared. And do we have any other y to the third? So we have 1 here and the last one here. So these are also like terms. Y to the third and 4y to the third. Hopefully that's helping you get the idea that the variable is what we're looking at to understand like terms. Let's do b as well. So I'm scanning here. I don't see any constants. And we have an x squared, an x squared, an x, and xy. Let's start with the lowest exponent, just to give some kind of pattern to it. So I see x to the 1. Do we have any other x to the 1? Yep, we got one right there. So 2x and 6x are both like terms. I'm going to cross those out because we've identified those. Do we have any other x? Yes, we have a 40x. That would also fit into there. So 40x. And I'm just crossing those out because I'm noticing that these are all like terms, and I want to make it easy for myself to see what's left. So those are like terms. What else do we have remaining? We have an x squared and an x squared. So these are like terms. So I have 4x squared and I have a 5x squared that are like terms. So got that. Any other x squares? Nope. And it looks like we only have one of these where it's a xy. So 8xy was my last term. So 3 sets of different types of terms. And that's how you would identify your like terms. Did we accomplish our goal? Absolutely. We always do. We talked about what a term is. A term is when you just have a constant or a constant multiplied by a variable. What's a coefficient? It's that constant that is being multiplied by a variable. So in this case, it'll be the 3. And how can we identify like terms? Well, we can just simply look at the the variable, and if they have the same exponent. So all the x squares come together, all the x's come together, all the y or xy's go together. So these are ways we can identify like terms, just to review. Thank you for tuning in again. My name is Clayton, the Algebra Guy, and I will see you next lesson.